Hi friends, today we're going to review for the performance tasks that you will be completing. Please remember that this is going to be a test grade recorded in the grade book. Okay, so we're going to classify polygons based on the presence or absence of parallel or perpendicular lines, or the presence or absence of angles of a specified size. Okay, the first figure that we're working with is a 1, 2, 3, 4, a 5-sided polygon. Any 5-sided polygon is classified as a pentagon. So if I can spell that out, pentagon. And you can see on our table we have number of right angles, number of acute angles, number of obtuse angles, pairs of perpendicular sides, and pairs of parallel sides. We're going to start with our angles first. So we have right, acute, and obtuse. Now the number of angles needs to be the same as the number of corners. So we have 1 corner, 2 corners, 3, 4, 5. So when we classify each of these angles, these 3 boxes right here should equal 5. So we're going to start with one of the corners. Here's our angle right here. Okay, I can see that this is wider than 90 degrees. I could even take out my little note card or piece of paper and line it up with the vertex and one of the rays to see if it is acute, right, or obtuse. So I know that this angle right here is an obtuse angle. Okay, now I'm going to go down here to this angle. This also is a wide angle. It is wider than 90 degrees. So this would be classified as an obtuse as well. Going over to this corner, this is the same as the opposite corner. This is an obtuse angle. And I'm going to keep working my way around the pentagon, and I get to this angle right here. It forms a perfect square corner. So this would be a right angle. And then over here, we have another perfect right angle. So I can see that I have 1, 2, 3 obtuse angles, and I have 1, 2 right angles, and I have 0 acute angles. So we said that the pentagon had 5 corners or 5 angles. So when I add 2, 0, and 3, they have to equal 5. If they do not equal 5, then I did something wrong. If it's less than 5, then I missed an angle. If I have a number greater than 5, then I counted an angle that does not exist. Okay, so always make sure that your number of angles equals the number of corners. Next up, we have pair of perpendicular sides. Anytime you have a right angle, you have a pair of perpendicular sides. So I know that I have one right angle right here. So that is telling me that this and this are perpendicular. So that's one pair of perpendicular sides. Over here, I have another right angle. I have 2 sides that form perpendicular lines. So on this pentagon, I have 2 pairs of perpendicular sides. If you have a right angle, you will have perpendicular sides. Now I'm looking for parallel sides. When we say pairs, that means that that is 2 lines that form parallel sides. So if I look right here and I look opposite, I do not have a line that is parallel to that. Same goes for this one. I do not have a side that is parallel to it. If I look at this side over here, and look at the opposite side, I can see that they are parallel. They are the same distance apart. They're going in the same direction. So that's one pair of parallel sides. If I look at this side and I look directly across, I do not have a side that is parallel to it. So this shape, this pentagon, has one pair of parallel sides. Our next shape is a triangle. Okay, so the triangle has 3 corners. Whoops. So I should have 3 angles. This should equal 3. So let's go look at here. Let's see. Well, if this was 90 degrees, the side would be going straight up. So this is less than 90, so this would be an acute angle. Same thing up here. This is less than 90 degrees, so that is an acute angle. And our last one, this one as well, is less than 90 degrees, so that would be an acute angle. So now I go down. Do I have any right angles? No. How many acute angles? 3. How many obtuse? 0. So when I add 0 plus 3 plus 0, it should equal 3, which it does, so I know I have all my angles. Pairs of perpendicular sides. Well, we have no right angles, so we cannot have perpendicular sides. Pairs of parallel sides. I have no opposite sides that are parallel. Okay, so that one was pretty easy. Let's go to the next one and our last one. Okay, we have another triangle. The triangle we did before this slide was an acute triangle because it had 3 acute angles. Okay, so we know this is a triangle. It's going to have 3 corners and 3 angles. So let's classify our angles. Let's start with this one. We have a perfect L, a perfect square corner, so we know that's going to be a right angle. Okay, let's go up to this one. This is less than 90 degrees, so that's going to be acute. And let's go down here. This is going to be acute. So we have a right angle, an acute angle, and acute angle. That makes this a right triangle. A right triangle will always have 1 right angle and 2 acute angles. Whoops, that's supposed to be a T. Right triangle. So a right triangle has 1 right angle and 2 acute angles. This is not easy. Okay, so let's go look at our angles. Number of right angles. We have 1 right angle. Number of acute, 2. Number of obtuse, 0. 1 plus 2 plus 0 equals 3. So we have all of our angles. Pairs of perpendicular sides. If we have a right angle, we're going to have perpendicular sides. So this side right here is perpendicular to this side right here. So we have 1 pair of perpendicular sides. Parallel sides. This side is not parallel to the opposite side. And this side is not parallel to the opposite side. They intersect. So we have 0 pairs of parallel sides. When you are completing your performance task today, make sure you're taking your time. Label all your angles and count them and make sure they match up. Take your time on this. It's not hard, but you've got to watch the videos and you've got to take the time to show your work. Have a good day.